So whenever we're talking about polynomial functions, it's important to know that it is a continuous function, and I might actually have to push the student out of their chair here in a moment. But it is a continuous function that can be described by an equation in one variable. Okay, we're not looking at two variables, three variables, whatever, but it is a continuous function. That means when you graph it, it's going to have something nice and pretty. You know, you don't pick up your pen to graph it. It's not like a piecewise function where you have to pick up your pencil and redraw it and all that kind of fun stuff. So it is a continuous function. If you know an element in the domain, then you're going to be able to find a corresponding value in the range. So what that means is in your domain, if we're talking about your domain, those are your x values. You're basically plugging an x in to find a y value. So when we look at example 2, here we're talking about respiration. So the volume of air in your lungs during a 5-second respiratory cycle can be modeled by this equation, where V is your volume in liters and T is your time in seconds. Oh my god, it's a word problem, I can't read. What we're going to have to do is you have to find your volume of air in the lungs 1.5 seconds into the respiratory cycle. So like most word problems, there's a whole bunch of words telling you what you need to look at, and then at the very end it tells you what you have to solve for. So for example 2, let's see, if we have our volume 1.5 seconds into the respiratory cycle, we're trying to find V if T equals 1.5. So you get to use your handy dandy calculator and just find V of 1.5. So we're going to plug all these numbers into your calculator. Don't forget to use your parentheses correctly. And then it's a cube plus, whoops, that's a little weird looking. We have a plus 0.152 times 1.5 squared plus a 0.173 times 1.5. And so when we plug all these values in, you find out that your actual volume after 1.5 seconds is going to end up being a 0.48 liters. So that problem wasn't too bad because all you're doing is just plugging your values in. So what I'd like for you to try is see if you can pause the video, see if you can find your answer for the try it, and then I will post the answer in about 2 seconds. So pause it now. Do it. Stop it. Stop. Pause it. So when you try it, when you plug in your values here, you have to find h of 1.25, and when you plug those in here, make sure you take -4, and then you have a 1.25, but you must cube the 1.25 before you multiply by -4, plus 6 times 1.25 plus 8 times 1.25. So when you plug those in, you should get the answer of A. If you did not get that answer, make sure you plugged it in, and you can just plug it right into your calculator looking just like this right here. That's why you have this big, lovely yellow calculators. That is how you evaluate